Today's lesson is Proportionality and Graphs Part 2. This is Lesson 9, and our goal is I can discern whether a graph is proportional or non-proportional. So we did most of this sheet yesterday, so I'm going to do a minute review on things that were covered yesterday, but it would be a very good idea for you to take time to complete yesterday's lesson. We skipped the upper part of the lesson and went straight to the heart of the matter. A proportional graph. So we're looking for proportionality in the graph, and a proportional graph, so we're going to highlight that, must have a straight line, so it must be a straight line, and it passes through what's called the origin, which is point 0, 0. It's where our two axes, the x-axis and the y-axis, come together to make this little plus sign, the center of that. That's called the origin. It's also known as a coordinate point 0, 0. So those two things must occur in order for the graph to be considered proportional. Now for a non-proportional graph, you may have noticed there is a straight line here, but it does not pass through the origin. And we'll talk about these type of graphs either later on this year or in 8th grade. You can also see a graph that's a curved line, and then this one is made up of lines, but it's line segments. It's not one straight continuous line. So these are examples of non-proportional graphs. So let's turn to the next page. We spent the bulk of our lesson yesterday on this page, and let's just remind ourselves one more time, proportional relationships in graphs are straight lines, and they pass through the origin. So if we're given just a little bit of information, we're going to be able to make a table. And once we make the table, we're going to be able to make ordered pairs. And once we make ordered pairs, we're going to be able to make a graph. So the x numbers came from this little statement. Tickets are $34 each. So when they say that word each, it means it's $34. Revenue is money for one ticket. The x values we just made up. They're called independent, so we just made them up. However, the y values depend on what we chose for our x values. So these are known as the dependent variables. So we already knew from this, because it said $34 each, that meant 34 for one, that the k value is 34. The k value is also the unit rate and the constant of proportionality. So we already have the k value from this statement. So we're also able to go right to the equation, inserting the 34 where the k was in the equation. And that's what allowed us to figure out the y values. 34 times 2 was 68. 34 times 3 was 102. 34 times 4 was 136, and so forth. Once you have your x and your y values, we're going to make ordered pairs, also known as coordinates. And this ordered pair is two numbers, but they make 1 point on the graph. So we must marry them together using parentheses so that we know that this is one thing, even though we see two numbers. So we now have our ordered pairs, which came from the x values and the y values. Now, if you haven't done graphing, then this is a part I want to go over. Our x-axis always goes right or left. You're going to notice this is x. So we move from what's called the origin, right or left. In this case, it's going to be right because we only had the positive numbers. The y values, this is the y-axis, go up and possibly down. In this particular graph, they only go up because we're using the y values, or we're using positive values. So here's how you graph. You start at the origin, you go over 1 on the x-axis and up to 34 on the y-axis, and we put a point right there. So this would be our first point from 134. The next point, we start at the origin, 0, 0. We go over 2 for the x-axis and up 68 for the y on the y-axis, and our point is 68. One more time, we start at the origin, we go over to 3 on the x-axis, and from that spot we go up to 102 on the y-axis. These two numbers work together to make these points. So you can probably already see a pattern. And since on our table we went only up to 7. I'm going to stop there, even though I completed the numbers on the graph. Finally, what we talked about yesterday before we left was that these points make a straight line. You can probably see that. If we run this line, we have a straight line. But those are the only points we have in our table. However, if we continued, it would indeed go through the origin. And this would make sense if I bought 0 tickets. I'd spend $0. And I could also figure out the rest of these without even putting them on a graph based on my, without putting them in a table based on my graph. So now that we have this, our goal is to now answer questions with all the information that was generated from that one statement. Tickets are on sale for $34 each. Question number 1. If the venue needs to sell 86 tickets to break even, then how much money have they invested in the concert? So when they say venue, that means the place where they're holding the concert. We're going to notice there's 86 tickets, selling 86 tickets, and tickets is an X value. Tickets sold, 86 tickets. When they say break even, it means to pay for the cost of putting on the concert. For instance, maybe renting the building or paying for electricity, whatever they may need to pay for the fact that the concert's going to be there. And then it says how much money have they raised. Well, Y is the money column. So we're going to first put our equation into play. So we have this equation, Y equals 34x. We're also given some information. We're given they sold, or they need to sell 86 tickets. And we talked about that tickets are the Y value, the X value. So we're going to write this equation, Y equals 34, and where the tickets are the X, we're going to put 86. So we're going to stop and use our calculator and find out how much that is. And that is Y equals 2,924. So again, what did we find out? Well, they ask us how much money they have invested in the concert. How much do they have to have? So they have to have $2,924. Let's go on to the next question. The venue has a maximum capacity of 200 people. If it sells out, how much revenue, that means money, will the concert earn? So when they say the maximum capacity of 200 people, well, people would be buying these tickets. So they're really talking about selling 200 tickets. So we're going to go back to our equation. Y equals 34x. And again, even though they're mentioning people to us, people are who buy the tickets. And they said the word sells out, so they're talking about tickets. And the question is, how much revenue, which is another way of saying money. So when you see revenue, they even mentioned it up here, total revenue. So once again, we're going to write Y equals 34, and this time we're going to put in 200. So again, pause, use your calculator, and figure out how much that is. So the answer is Y equals 6,800. So again, revenue means it was $6,000, $6,800. The next question says, describe how you know this is a proportional relationship. Well, the easiest way is just by looking at this graph. What do we see? We see a straight line that passes through the origin. The nice thing about graphs is they're very visual. We see a straight line that passes through the origin. So visually, graphs are awesome for that. Our next question, what does the ordered pair 0, 0 represent in this situation? Well, this situation is the number of tickets, 0, so 0 tickets, and the total revenue, the cost, well, 0 cost. So we could write 0 tickets cost $0. So the final question today is, what does the ordered pair 6, 204 represent in this situation? So I'm going to give you a time to think about that. Well, we do see our ordered pair 6 and 204, but that came from 6 tickets and $204. So in this situation, this means 6 tickets cost $204. So that's all for today, and thanks so much for watching. Take care.